What is the purpose of the root bridge with spanning tree protocol? Well, in a nutshell, it's a reference point. It is the starting point or the seed that is planted in order to grow the spanning tree. So everything's going to begin at this root bridge. So once the root bridge is determined, from there the rest of the tree can be built. The branches, the twigs, the leaves, all that's going to grow out of this root bridge placement. And it's important to realize that all spanning tree paths in the topology are going to lead back to the root bridge. Therefore, it's very important that you optimally position the root bridge within your topology. And typically that's going to be at either the distribution layer or the core layer. You never want to have an access layer switch as the root bridge, because then traffic would have to be forwarded through the access layer. And we don't want that to happen unless the traffic is destined for the access layer. If it's not, then it should not go through the access layer. So always keep that in mind. Now, when we elect a root bridge, there is going to be one per VLAN. What's another name for a VLAN? What's another name for a VLAN? That's right. Broadcast domain. What's another word for broadcast domain? Subnet. So what does that mean? It means you will have one root bridge per VLAN, per broadcast domain, per subnet. You have 10 subnets. You have 10 VLANs. You have 10 root bridges. Now, if all those VLANs are on the exact same switches in the topology, let's say we had 10 VLANs on all of these switches, then we would have 10 root bridges, one for each and every single VLAN, broadcast domain / subnet. And by default, they're all going to be the exact same switch, because the calculation that's being performed by default is based on all the exact same information, all the same parameters. But then you can start modifying those values on a VLAN by VLAN basis and start to manipulate your spanning tree topology. So root bridge is going to maintain the topology. It is the seed, the starting point of the creation of the spanning tree. And always remember that timers are going to be propagated from that root bridge. So even if you change the hello timer or the for delay timer or the max age timer on other switches, it doesn't matter unless that switches the root bridge, because the root bridge will tell the other switches these are the timers we're currently using, and they will use them. And those timers are sent through what? Bridge protocol data units. So how do we elect this root bridge? Let's look at what happens. It's elected through the exchange of BPDUs between switches. So there's information in that BPDU which can be utilized for this root bridge election process. And if we examine the BPDU, you will see that each switch sends their bridge ID within a BPDU. And it's this bridge ID that's going to be examined by all the different switches so they can ultimately determine who the root bridge is. In addition to that, the root bridge ID is going to be listed as well. So if two switches already agree that one of them is the root bridge, well, this switch indicates in its BPDU, well, here's the current root bridge I know about, here's the sender, and this is my bridge ID. And another switch compares all that information and says, well, I'm way better than those two values, so I'm now the root bridge, and the other switches comply, saying, all right, great. I agree. So therefore, we now have a new root bridge in the particular topology. So how does this election work? Well, the devices are going to compare the bridge IDs and ultimately look for that switch with the lowest bridge ID. Now, what is the bridge ID? It's made up of two parts, two extremely important parts. One is the bridge priority. And we can see the bridge priority right here. What is this bridge priority? It is a 16-bit value in the range of 0 through 6,500 or 65,535. 65,535. And what is the mid-range point? The mid-range point is the default value that we see down here, 32,768. So out of the box, the Cisco Catalyst switches have a default priority of 32,768. So this information is inside the bridge ID in that bridge protocol data unit that's being sent. In addition to that, there's a second portion, which is the MAC address. And we see the MAC address right here. So a 48-bit MAC address is being sent as well. So now this information is compared between the two switches. And if we look below, there's the priority and there's the MAC address. There's the priority, there's the MAC address. We're looking for the switch with the lower value. So what is it? Switch X or switch Y? That's going to be the root bridge in this case. Take a good look. If you're struggling with this, it's because I haven't given you all the information you need. First and foremost, we are looking for the lowest bridge ID. But you have to understand here that these two parts are taken individually. Bridge priority is looked at first. Which of these two switches have the lower bridge priority? Well, they're tied. You see that? 32,768, that's a tie. With spanning tree protocol, ties are not acceptable. Let me repeat that. With spanning tree protocol, ties are not acceptable. There always has to be a tiebreaker. So in this case, what is that tiebreaker? MAC address. And in this case, switch X has this MAC address. Switch Y has this MAC address. So remember this rule for spanning tree protocol. Lower is better and ties are not acceptable. Let me repeat that. Lower is better and ties are not acceptable. If you always remember that rule, you'll be able to walk yourself through the spanning tree process. So who has the lower MAC address now? See, the bridge priority is tied, so we need a tiebreaker, the MAC address. Which one is lower? If you're not sure how to read this MAC address, you read it from left to right. So compare the values. 0, 0, same. C, C, same. 0, 0, 0, 0. All right, then we have 1 and 2. Oh, right there. There's our deciding factor. This 2 and this 1. 1 is lower than 2. Therefore, switch X is our root bridge because it has the lower bridge ID. Now, what if the priority of switch Y was 0, as an example? Or maybe even 4096 as an example. Well, in this case, as you're trying to elect the root bridge, which one has the lower bridge ID? You start by examining the bridge priority. In this case, bridge priority is 32,768 for switch X, and we'll go with 0 for switch Y. Which is lower, 32,768 or 0? 0 is lower. Therefore, in this case, this would be our root bridge. We didn't have to look at MAC addresses because the priority was able to, on its own, determine who the root bridge was. Make sure you know how to do this. This is a very important skill to have because this is the planting of the seed. Once you figure out who the root bridge is, then the spanning tree can grow from there.